Could you tell us first of all your name and what year you were born?
Well, my name is Lesley Collier, and I was born in 1922, September 22.
And were you born in Doncaster, Les?
No, in Swindon, Wiltshire.
And is that where you first worked?
Yes.
Could you tell us about that first job that you had?
Yes, my first job was an office boy, which I started work when I was 14 and a half in Swindon, and I started in 1937, and I worked in the office for nearly a 12 months till I was 16, to 6 months till I was 16 years of age, when I went for my apprenticeship as a pattern maker for 5 years, which was quite an interesting period of time. Well, I had to work on all types of patterns, during which time the war broke out, and we even helped in constructing the patterns for the Churchill tank.
During the war, that would be?
During the war, yes.
Yes. Was that because the engineering works was made to do war work?
Yes, we went on to quite a lot of war work in that period.
And then when did you move to Doncaster?
I moved to Doncaster in 1946.
And did you get a job at the Plant Works?
Yes, in the July of 46 I started in the Plant Works. And it was a very interesting move to make, because I've enjoyed every moment I've been here.
Did you know about the Plant Works before you came?
No, strangely enough, no. I just got to hear about it through a colleague, and he said there was a vacancy for a pattern maker, and I came up here, and the supervisor in the pattern department was only too pleased to accept my services. He was Mr. Needham.
And could you try to explain to us what a pattern maker does, especially in relationship to the engine, the trains, the locos that were built at the plant?
Well, I will try to give you an idea from a book written by a friend of mine who summed it up, I think, admirably. The art of pattern making is undoubtedly one of the most interesting branches of engineering. Outside the pattern shop and allied departments, the knowledge of the methods adopted to obtain a casting is often very vague. The successful pattern maker must possess the faculty of visualizing the finished article from the drawings, and also he must be capable of making his own drawings, which we often did. We drew anything that was scaled drawings, we used to draw full size, adding the machining allowances if the castings were going to be machined up afterwards. A sound knowledge of the moulder's craft is essential, as the construction of the pattern frequently governs the method adopted in the foundry. Also, in instances where a casting requires machining, the capabilities of the machine shops must be taken into consideration. Allowances for the contraction of the various metals are fixed, but the pattern maker knows from experience that these allowances are not definite. The shape of the castings often results in one type of work shrinking more than another, although cast with the same metal. Contraction rules can be obtained with the necessary shrinkage allowances marked, which are as follows: steel, 1/4 of an inch in 15 inches, brass, 1/8 of an inch in 10 inches, cast iron, 1/8 of an inch in 15 inches. With the use of these rules, the pattern maker need not worry about construction, save in exceptional work. So, as you can see, that you have to bear in mind that a pattern, once it's made, has got to be able to be extricated from the mould. And I have brought a mould here and a very simple pattern to illustrate it.
Okay, you show us how this works then.
This is a very simple pattern. It's a joining piece, but we will take for the moment that it's going to be cast in brass, the finished product, which would look like that. Now, to get this out of the mould, it's made in 2 halves, and they're doweled together so that when the moulder puts them together, they form the complete model of what's to be made. The moulder then has the job of putting this into the mould, so, and he would fill it with sand up to the full size of the pattern of the half that's in there, and then when he's levelled it all off, he would then put the other half of the pattern on it, so, and he would place this top box, which would be empty of sand, and place that back in position. He would then ram it up with putting that in first, because this part of the proceeding is to allow that when the mould is fully formed, he's able to scrape this off, take out this, what they call runner stick, and the metal, when he pours the metal in, will be able to go in and fill the mould. But prior to doing that, he must take the pattern out so that he's got the impression of the finished object inside the mould. The pattern is then put away for the next casting. The mould is then closed and ready to receive the metal, which could be either brass or iron or whatever, to get your casting. When that's been cast, the moulder then, after a period of time when the metal's cooled, he just lifts off this mould, and inside, now in metal, is a reproduction. The full thing is in either brass, iron or steel, whatever he's casting metal he's using. He can then take it out and it's all in one piece. And then they can then either machine it to whatever size they require. If they want to bore a hole down through there, they can do so. It's entirely up to whatever's decided in the machine shop. And if it was a very large casting or a complicated casting, they would have, we would then use a method known as a core, which would give the hole and the internal shape that they wanted inside this casting. And that would involve the pattern maker making a core box which would reproduce whatever was required inside the casting. So the metal then could only flow round the core and fill out the rest of the impression made by the pattern.
So if you were making a cylinder, then you'd need the core.
That's correct.
Cylinder shape.
That's correct. Yes, indeed. That was the principle, in a very, very simple way, of how they arrived at it. Of course, the pattern makers had to envisage all the problems that would be entailed in extricating more complicated patterns and cores, whichever he's going to be making, you see.
So at the Plant Works, you would work closely with the drawing office,
yes,
wouldn't you?
Yes.
Because the drawing office produced the drawing.
Drawing, yes.
And then from that drawing, you made a full-size version of it.
That's right.
In order to make your pattern.
Exactly. Sometimes it would result in us having a board probably 10 or 12 feet long, according to what and we would draw the thing out in full size. Whatever the casting would, we'd draw it in full size, and then add any machining allowances, and then we would work from that to construct the main patterns.
For example, if you were making the pattern for a wheel,
yes,
of this size.
That's right, yes, they would be full size.
That's right.
With the allowances for shrinkage on casting. Yes, yes, they would be, definitely.
What sort of wood did you make the pattern with?
The patterns could be made if it was with a pattern not requiring a lot of wear, could be made with yellow pine, best yellow pine. A pattern that was going to have a number of times use would be made in mahogany, which is a harder wood. Or you could use beech, which again is a very close-grained wood and would stand up to quite a lot of wear. Should there be hundreds of reproductions, the pattern could be made in metal and with the appropriate allowances, and they would be probably done on a plate. That would be a piece of steel, and you'd have a number of these like across a plate. Yes.
But every pattern was then used by the moulder in this particular way that you've demonstrated here.
Exactly, yes.
And then who finished the final metal piece? Was there a finisher?
When the impression was made in the sand and coated, sometimes they used to coat the insides of the mould with a material called plumbago, which was like a wash they put on to give a smooth finish. But apart from that, the castings then went to a fettling shop where all the parts like this, which would still be stuck on, would be broken off and cut off, and then they'd go then to the machine shop to be machined up.
Did you have a machine that you used to make the actual wooden pattern?
Oh yes, we used lathes, bandsaws and universal woodworkers, planing machines and sanding machines, which took a lot of the finishing and made it a lot easier.
Yes.
Yeah.
So it's a very skilled job, wasn't it?
Yes, because to see a series of lines on a drawing and then work out just what was required was always a little bit involved at times, you know.
Yes.
Yes, sometimes when I've been at home, I've thought of another way of doing something, you know.
It's the sort of job that you think
Yeah,
about all the
thinking
time.
about, yeah. But it's a very interesting craft.
I
Very.
remember you said that when you had an apprentice, you used to say to them that the rule of the pattern maker is think, and
Think, that's correct. Keep thinking, yeah.
because of the measurements and because of the different
Exactly.
contractions of the different metals.
And I'm afraid it rubs off in your everyday life a bit, you know.
Yes. So did you have an office at the plant work where you worked? Were there other pattern makers working
About 15 or 16 pattern makers, yes. And we all had our bench where we used to be able to do our work and then go across to the machines and use them. The lathe was indispensable in the making of patterns, so we had to have a knowledge of lathe work, turning up items such as this, you see. And the rules used to puzzle visitors because they'd pick up your rule and they'd see all these different sizes, you see. There was the standard size on the top part of the rule, but then they'd see another size for brass, another size for steel. So they just wonder what they were.
That's right. That's right. So we're talking about here parts that were made for steam engines, aren't we?
Yes, yes,
Because there were
yes.
steam trains when you first came to work.
Oh,
at the
yes,
plant,
yes.
Everything that was made was on a steam train, wasn't
That's
it?
right, yes.
So your work was part of the finished engine.
Engine, yes.
Yes.
That's right, yes.
Can you remember the changeover era, Les, where the last of the steam trains and then moving on to
Yes,
diesels?
we did think in the works at one time that maybe we'd go on to making the parts for the diesel engines, but it was English Electric that supplied the first diesels, and they had their own staff that maintained them, but we were never making parts for them to that extent at all.
So what happened to the pattern maker's job then at the plant?
Gradually they went to other firms and took up the trade in other industries. Yes.
And you in particular?
In my own field, I just went over to the diesels on the fitting any panelling or anything like that, which they allowed us to do. We could maintain the diesels, but not make parts is like castings and such like. No,
That's right.
because I suppose trade regulations, you see.
And the panelling that you made for the diesels was the kind of housing where all the ducts came from.
Yes.
The
That's right.
parts
Yes.
on the front.
Yes, that was all all parts that was covering up in that sort of
And
thing.
what was that made out of?
That was made of plywood, and it was, in some instances, it was covered with formica. So it was easily able to be cleaned and things.
Yes. So at that period in the plant work, did people have to be retrained?
There was, yes, from the fitting point of view, maintenance, yes, they did quite a lot of maintenance to the diesels. The fitting staff had to go to courses, and some of the courses, and they were given an insight into the complete change of direction. And a lot of my friends were actively employed in maintaining the diesel fleets, which was quite complicated for them, really. With the,
for example, a boiler maker on a steam engine.
Yes.
What would he do on a diesel engine?
He could come into play with metal parts that were on a diesel, that such as plating, and it could be employed on the plating side, which was more or less just switching over to a more simple thing.
And then after diesel, there were high-speed
electrics,
weren't there?
Yes.
So then we'd need electrical engineers.
That's right.
Plant Works, wouldn't we?
Yes. Well, when the electric locomotives came in, there was a number of people that were employed in making the panelling for all the electrical stuff. You see, a lot of electricians were employed on the electric locomotives, and also quite a lot of fitters were required. So they were still kept going quite well, maintaining, and actually we did build the chassis and all the rest of it, and all we purchased then was the generators and all the motors and things. They were all supplied by private manufacturers.
That's right.
Yeah, we couldn't make those. No. So it was.
Can you think of any dangers that there were working at the plant, Les?
Oh yes, overhead cranes carrying 80-ton or 90-ton loads were always a case to be reckoned with, to keep well clear, because they travelled the full length of the very long building shops, and it was only of later times that emphasis was given to goggles and helmets and all this sort of stuff, you know.
But you told me about the danger of working with asbestos, that it wasn't.
Oh, asbestos?
realised.
No, it wasn't. A lot of my colleagues died of asbestos poisoning, yes. A lot of my colleagues died through inhalation of the fibres, you see. But it was used extensively for covering the boilers to keep the heat into the boilers, and it was used like a plaster over the shell of the boiler. Yes.
And they didn't realise the danger.
Didn't realise the dangers. No. No, blue asbestos was the worst of all, you see, because apparently that's the most poisonous. It was quite an experience.
And working on machines yourself, did you ever have any accidents?
No, no.
Very good then. Yes, but there must have been some accidents.
There was some
with
accidents.
Fingers and
yes.
calling the nurse. And
yes, you had to keep alert, and it wouldn't do to speak to somebody who used the machine, else you'd get a very sharp answer.
Yes.
Yeah.
Yes. It was a job that you certainly had to concentrate on.
Yes, all the time. Yes, yes. While you were doing it, that was the main thing to keep doing, was concentrate, and you had a discipline about your tools, making sure your tools were always very sharp. Blunt tools were dangerous, very dangerous. Sharp tools, quite safe.
Yes.
And considering that some of the machines went up to a very high revolution, that was again a big assistance for a good cut. with the appropriate cutters. Yes. Oh yeah, it was...
There was the, in the plant works, I believe, there was this hierarchy of you had respect for those who were over you.
Yes, that's right. You had your locomotive superintendent of the chief mechanical engineer, and then you had superintendents above, just below him, and then you had your foreman, who were in charge of departments, and then came to them, the departments were divided up with chargemen, who had a group of men under his jurisdiction. And it all worked out very well. Everybody knew their places, to coin an old-fashioned phrase, yes. Yes, it was quite interesting.
Well, thank you very much for coming and telling us about your work. It's been really interesting, and this, I'm sure, will help the children to understand about how a pattern is made.
I trust so. I trust so.
Thank you very much, Les.
Thank you too for everything, Jenny.